Imagine looking into the night sky and realizing that something enormous is silently moving toward our cosmic neighborhood. No bright tail, no warning signal visible to the naked eye, just a mysterious object traveling through the darkness of interstellar space. It has no home star, no predictable orbit, and no clear destination. Now, imagine astronomers suddenly detecting it as it crosses the edge of our solar system. Could this wandering giant rewrite everything we know about our place in the universe? The universe is far from peaceful. It is filled with wandering worlds, rogue planets, ancient stars, and mysterious objects that drift freely through the galaxy without belonging to any solar system. Some were violently thrown away from their parent stars billions of years ago. Others may have formed completely alone in the darkness between the stars. They travel endlessly through space, unseen until they wander close enough to be discovered. Now, picture scientists identifying one of these massive objects approaching the outer reaches of our solar system. The discovery immediately raises countless questions. How large is it? What is it made of? Is it simply passing through? Or will the sun's gravity alter its path? Every telescope suddenly turns toward this mysterious visitor as researchers race to gather as much information as possible before it disappears back into the endless void. The outer boundary of our solar system is unimaginably vast. Beyond the known planets lies a frozen region filled with icy bodies left over from the birth of the sun. If a massive rogue object enters this region, even a distant passage could slightly disturb the delicate gravitational balance. Tiny changes over millions of years could redirect comets, alter distant orbits, or provide astronomers with an extraordinary opportunity to observe gravity at work on an enormous scale. The greatest challenge is uncertainty. A mysterious cosmic visitor appears. A massive rogue object from interstellar space is detected entering the outer reaches of our solar system, raising excitement and countless scientific questions about its origin, size, and destination. Imagine a routine night at one of the world's most advanced observatories. Astronomers are carefully scanning the darkness beyond the known planets when a faint point of light suddenly appears in their data. At first, it seems like an ordinary distant object, but repeated observations reveal something astonishing. It is moving on a path unlike anything normally found in our solar system. Instead of following a familiar orbit around the sun, it appears to have entered from the vast emptiness between stars. As more telescopes begin tracking it, scientists realize they are witnessing the arrival of a mysterious rogue object that has likely spent millions or even billions of years wandering through interstellar space. News of the discovery spreads rapidly throughout the scientific community. Researchers work around the clock, comparing observations and refining calculations to determine the object's size, speed, and trajectory. Every new measurement raises fresh questions. Where did it come from? Was it once part of another planetary system before being thrown into the darkness by a violent gravitational event? Or has it traveled alone since the earliest days of the galaxy? Although there is no immediate evidence that it threatens Earth, its arrival represents an extraordinary opportunity to study a visitor from another region of the Milky Way. The discovery reminds us that the universe is full of hidden travelers, silently crossing unimaginable distances before briefly passing through our cosmic neighborhood. What is a rogue object? Explain how rogue planets, stars, and other celestial bodies are ejected from their home systems and travel through the galaxy without orbiting any star, making them some of the universe's greatest mysteries. Unlike the familiar planets that circle the sun in predictable paths, rogue objects follow no permanent star. These mysterious wanderers drift through the galaxy alone, traveling across immense distances where almost no light exists. Many scientists believe some of them were once ordinary planets orbiting distant stars. During the chaotic early stages of planetary formation, powerful gravitational interactions may have flung them into deep space, sending them on endless journeys that lasted billions of years. Others may have formed in isolation within giant clouds of gas, never becoming part of a traditional solar system at all, because they receive little or no warmth from a nearby star. These objects are incredibly cold, making them extremely difficult to detect until they pass close enough for sensitive telescopes to notice. The discovery of such an object entering our solar system would offer an extraordinary scientific opportunity. Every detail, from its composition to its motion, could reveal information about regions of the galaxy that humanity has never directly explored. By studying its surface and behavior, astronomers might uncover clues about how distant planetary systems evolve and why some worlds become cosmic outcasts. Rather than simply being another object in space, this lonely traveler could serve as a messenger from another corner of the Milky Way, carrying secrets that have remained hidden since long before Earth itself was formed. Could it affect our solar system? Explore how the object's gravity might influence the distant icy regions beyond the planets, potentially disturbing comet paths and offering scientists a rare chance to study gravitational interactions. When a rogue object enters the solar system, the first challenge is not fear, but understanding. Astronomers immediately begin tracking its motion with precision instruments, mapping its trajectory against the background of known celestial bodies. Because such an object has traveled from interstellar space, its path does not match the familiar patterns of planets or asteroids that belong to the Sun's gravitational family. This makes prediction extremely complex. Even a small change in speed or direction, caused by the Sun's gravity, can alter its long-term path in ways that take time and advanced modeling to fully understand. At the same time, scientists analyze the light reflected or emitted by the object. This information helps determine its composition, whether it is rocky, icy, metallic, or a combination of materials never before seen in such a visitor. Each new detail adds to a growing picture of a world that formed far beyond our reach. For researchers, this is not just another space object, but a rare opportunity to study material from another part of the galaxy without leaving our own system. As data continues to arrive, global observatories collaborate, sharing findings to refine predictions. Slowly, uncertainty turns into clarity, and the mysterious visitor becomes a valuable scientific record of cosmic history traveling silently through our neighborhood. The scientific race to understand it. Describe how astronomers worldwide use powerful telescopes and advanced calculations to determine the object's speed, composition, trajectory, and whether it poses any long-term significance. The greatest significance of a rogue object passing through our solar system is the window it opens into deep cosmic time. Unlike planets that have remained in stable orbits for billions of years, this traveler carries evidence of conditions that may exist far beyond our observational reach. Every particle on its surface, every trace of ice or dust, may hold clues about environments shaped by entirely different stars, different radiation levels, and different gravitational histories. By studying it, scientists are essentially reading a physical record written long before humanity existed. There is also the possibility that its passage will subtly influence the outermost regions of the solar system. Far beyond Neptune lies a vast, invisible reservoir of icy bodies. These distant objects are loosely bound by the Sun's gravity, making them sensitive to external disturbances. A massive intruder could slightly shift their orbits, sending some into new trajectories that may take thousands or even millions of years to unfold. While such effects would not pose an immediate danger, they highlight how interconnected and delicate celestial systems can be. Ultimately, this rare encounter reminds us that space is not empty or static. It is a living, moving environment filled with unexpected visitors that reshape our understanding every time they appear.